Hi guys, it's Miss Richmond here. I'm doing the week 7 mass to mole conversion. Sorry, I'm trying to move my camera. Okay, I'm doing the week 7 mass to mole conversions, the two-step conversions. I'm just going to do a couple problems from here. In virtual classroom, if you were there, we went over questions 1 through 6. So actually in this video, I'm going to do something a little different. I'm going to go over number 8 and 9. And then if you were not or are not able to attend virtual classroom, you can go back and do those first couple problems as well as the last few. So the basic idea here, this problem set, this mass to mole conversions, these are two-step conversions. So we have practiced now using molar mass as a conversion factor to go from grams of one substance to moles of that same substance and vice versa. And we've also done mole to mole conversions. So looking at a balanced chemical equation and using the mole ratio to convert between, let's say, like moles of one reactant and to moles of one of the products or something like that. So this week we're going to take it a step further and actually go and do like mass of one substance, so grams of one substance to moles of a different substance. So it's kind of combining two of the skills that we already have and kind of expanding it into now doing a two-step conversion rather than just one-step conversions. So watch this video for your instructions, and then you'll complete the remaining problems on your own. Again, as always, make sure to click Turn In on Google Classroom once you have finished the assignment. Sorry, my boyfriend just came home. So I'm going to shut that. Okay. So make sure you click Turn In. Grades are totally updated with... The dog just opened the door and came out. All right, hopefully it's actually shut now. Grades are totally updated with stuff from like since the closure. So if you turned something in or thought that you turned something in, just go back and double check and make sure that you actually click turn in if you got a missing marked on it or anything like that. Okay, so in terms of background, chemists use balanced chemical equations as a basis to calculate how much reactant is needed or product is formed in a reaction. This is called stoichiometry, right? What we've been working on for quite some time now, and we'll continue to work on really until we get started on like our final project. Another way of looking at it is using the mole ratio. From the balanced equation and information. I'm trying to record a video. Another way of looking at it is using the mole ratio from the balanced equation and information about one compound in the reaction to determine information about another compound in the equation. A mole ratio is a conversion factor derived from the coefficients of a balanced chemical equation interpreted in terms of moles. In chemical calculations, mole ratios are used to convert between moles of one thing and moles of another. So this week we're going to not only use the mole ratio to convert between two different substances in a balanced chemical equation, but we'll also use molar mass to then convert even one step further. So the first example is given to you. Again, I'm not going to go through this. We did this in virtual classroom, but that's questions 1 through 6. And they're showing you basically here's a question and here's how they solved it. So come back and look at this if you feel like you need more guidance after I go through number 8 and 9. What did I say? Yeah. So we're going to do 8 and 9, the first part of the you try now. So we're given a balanced chemical equation. We have 4 moles of phosphorus, P, combining with 5 moles of O2, oxygen gas, and that's producing 2 moles of P2O5, phosphorus oxide. The first thing that we need to do is determine the molar mass of P, this substance here, and it just says use your periodic table. So I'm going to open up my periodic table, which is linked actually in number 5, and figure out what my molar mass for phosphorus is. So P is over here, zoom in, and that's 30.97376. Is that a 6? Yeah, 6.2. I'm going to round that. You can round that to, I'm going to say 30.97 just to be super accurate, but you could also round it to 31. So for number 8, my answer is going to be 30.97 grams per mole. And remember, that's basically what that means is there's 30.97 grams of P in 1 mole of P. My dog and boyfriend just went on a run, so my dog is panting very loud in the background. She's like laying out here and just panting. Anyway, all right, now we're going to do number 9. This is a conversion problem, right? How many grams of P, phosphorus, this thing here, this substance here, are needed to form 8.2 moles of P2O5. So like, let's put this in some context, right? If you're a scientist, you work in a lab, and you're trying to produce, you're like, we got this order in for 8.2 moles of phosphorus oxide, right? So what do I need to do in order to make that? What am I going to need to start with? How many grams of P do I need to measure out in order to make this happen so I can supply this amount, this very specific amount, 8.2 moles of P2O5 for my customer, right? So that's what this is, right? That's what we're trying to figure out here is how do I make what I want to make, essentially? What do I need to start with in order to get there? And we need stoichiometry in order to figure that out. So I'm going to use my conversion factor steps just like normal. So my first step, determine my given value and my desired ending unit. So I'm given in this problem 8.2 moles of P2O5. That's what they give me. That's the number that I know. And then my desired, what am I trying to figure out? I'm trying to figure out how many grams of P I would need in order to make that, okay? So we have step 1, determine our given value and my desired ending unit. Now I'm going to draw out the map going from given to desired. These are 2-step conversions. That means we have 2 steps. We not only have just straight given to desired, we have like an intermediate step. So we go given to intermediate step, that's step 1, then intermediate step to final desired, that's step 2. And we're gonna be working on 2-step conversions for a couple weeks, and then we'll move on to 3-step conversions. So it just kind of builds on each other, right? That's why we have all this background. We're kind of putting it all together now. So starting with my given 8.2 moles of P2O5, I have my intermediate step. The intermediate step is where we use the mole ratio to go from moles of my given substance to moles of my desired substance. So we're going to convert that to moles of P, because that's what we want to ultimately end with, is just phosphorus. And then we can go from moles of P to grams of P. I can't go directly from moles of P2O5 to grams of P because we don't have any conversion factor that directly compares those two things. So we have to have that intermediate step when we're doing these 2-step conversions. Okay, so now I'm going to figure out how are moles of P2O5 and moles of P related. So for that, I need my balanced chemical equation and the mole ratio between P and P2O5. So for every 2 moles of P2O5, there are 4 moles of P. That's from the balanced chemical equation. So that's what I'm going to put here. 2 mole P2O5 equals 4 mole P. And I got that from the balanced chemical equation. 2 moles of P2O5, that's this 2 here, to every 4 moles of P. That's this 4 here in front of the P. It's the coefficients. So I'm just going to write over here mole ratio, because that's where that came from. I'll just make that smaller. Okay. Now we want to get from moles of P to grams of P. Remember, we already calculated the molar mass that compares moles of P and grams of P. So I'm actually just going to copy that, put that here. That's my molar mass of P. My conversion factor there. So we've now done steps 1 and 2 for our conversion factor problem. Step 3, the best step, just put the given over 1, the easiest step, 8.2 moles, P2O5, and we put that over 1. I like to spread it out more. And then we need to solve using desired over given for every step in our problem. So we're going to have 2 steps, right? So 2 like conversion factors, basically. So our first desired over given, in this first step that we're doing, the desired over given, we're going from moles of P2O5 to moles of P. So our desired is moles of P, so we want this 4 mole P on top. And our given in this first step is moles of P2O5. So we're going to do desired over given. Now in our second step, we're starting with moles of P and ending with grams of P. So our desired is grams of P. So this one would go on top, desired over given. And our given, we start here with moles of P. So we want this on the bottom. All you have to do from there is like plug it into your calculator and solve. I'm not going to do it for you because I'm not going to solve the whole thing for you. But you really would just do 8.2 divided by 1 times 4 divided by 2 times 30.97 divided by 1. And you should be able to figure out how many grams of phosphorus you would need and answer your question ultimately, right? How many grams of phosphorus are needed to form 8.2 moles of P2O5? You'll be able to figure that out. So go ahead and finish up 10, 11, 12, and 13, as well as this top part 1 through 6, where you're kind of breaking down this example that they give you. If you have any questions, you know how to get in touch with me. Thanks for watching.